Today we're going to be looking at question 5 on the Fall 2021 Exam 2. The question asks us, which of the following insertions results in the 2-3 tree below? Before we look at this specific 2-3 tree, I want us to go over what 2-3 trees do, how they work in general, and that way we can better answer this question. So remind yourself about the fact that a 2-3 tree works because it only consists of 2 nodes and 3 nodes. A 2 node is a node that just has one value in it, and so it has 2 keys. The keys are the areas in between the values of the node or outside the value. So this is a 2 node. And then there's also a 3 node. And the 3 node is the exact same thing, but just when we have 2 different values in the node, and that way we have 3 different keys. A 2-3 tree only exists, it only is comprised of these 2 different types of nodes. And so whenever we insert a value such that a 3 node becomes a 4 node, that's when we start splitting nodes up. So let's take an example here. Let's say that we want to insert in the order of 4, 5, 3, 1, 2. For the first node, we just make a new node for it because there is no node that has existed before. We place the 4 down there. Now we want to insert the 5. Inserted the 4 already. We want to insert the 5. And so the 5 goes down. The way that the 2-3 tree works is that we keep going down until we have reached a leaf node, and that's when we can insert our value. So because of the fact that this 2 node that holds the 4 is a leaf node, we can just go ahead and insert insert the 5 right into this node. So 5 is greater than 4, so it goes to the right of the 4, and we put it right here. And so that makes this 2 node turn into a 3 node because now we have 2 different values in here. Next, we're going to insert the 3. The 3, again, is going to be inserted into this 1 node because of the fact that it is a leaf node. And so the 3 is going to go to the left of the 4 and the 5 because it is less than both of them. And it's going to turn the 3 node into a 4 node. Now, if you remember, whenever this 2-3 tree is not allowed to have 4 nodes, it's only allowed to have 2 nodes and 3 nodes. So to reconcile that, we need to raise up the 4 and drop the 3 and the 5 into new nodes. So we're going to delete this, and instead the 4 is going to go up, and the 3 and the 5 that used to be paired in that same node are going to have their own nodes. Next, we can insert a 1. A 1 is going to be less than 4. And so the reason that we're comparing it is because we are no longer inserting the 1 at a leaf node. Now we are starting at the top, and now we actually need to do our first comparison to find out which node this should go into. So the 1 is less than the 4, so that's when we drop down to this 3. And now, because we're in a leaf node, we can go ahead and just insert the 1 into the node with the 3. And this node now goes from being a 2 node to a 3 node. Next, we're going to insert the 2. We compare the 2 with the 4, and we see that the 2 is less than 4, and so it drops down into this. Because this is a leaf node, again, we are going to insert the 2 right in there. It's going to go between the 1 and the 3, because it is more than 1 and less than 3. And so now we've turned this from a 3 node to a 4 node. Once again, we are not allowed to have 4 nodes in this 2-3 tree. So the way that we need to do it is that we need to drop the outer 2 and raise up the inner value. And the way that this works is that we raise the inner value of 2 up to the level with the 4. And then we're going to drop the 1 and the 3 to be the 2 children, the 2 keys of that 2. And this is the part that a lot of people get confused about because it's a little bit strange. So we are going to have the 2 rise up to the 4 there. The 5 still stays at the end. But now we have 2 more children, 2 new children of this 3 node. That's going to have the 1 and the 3. Take a second to try to get familiar with this because this is where people tend to struggle the most. in that when you have a 3 node go to a 4 node, and you need to move it back into 2 nodes and 3 nodes, because we're in a 2-3 tree, you're going to rise the 2 up to the higher level, and you're going to take the 2 different values that surrounded it and make it into the 2 new children that bound the 2. And so now this 3 node with the 2, 4, the 2 and the 4 have 3 different children. You need to take some time to replay that part of the video, that is fine. But we're going to move on to the actual question itself now and look at these values, and maybe the example here will also help you to understand it better. So the first insertion sequence that it gives us is 49, 34, 8, 12, 25, 5, 53, and 29. We first insert the 49, and as normal in any tree, if it's the first value, it just goes right in there. No work needed. Next, we're going to insert the 34. 34 is just going to be less than the 49, and it's in a leaf node already, so we can just go ahead and insert it in there. And so now this 2 node has gone into it, became a 3 node. Next, we're going to insert the 8. The 8 is less than the 34 and the 49, and so it's going to go to the left of both of these to make some room. 8, 34, 49. And so now we've gone from a 3 node to a 4 node. If you remember from our example, this means that we need to split things up. So the 2 outer values are going to go down, and the inner value is going to go up. So we're going to become 34 at the top, 8 here, and 49 here. Next, we need to insert 12. 12 is going to look at the 34, and it's going to see that the 12 is less than 34, and so we drop to the left subtree. Because we're now at a leaf node, we can go ahead and insert the 12 into the node with 8. And so this 2 node that has an 8 becomes a 3 node with an 8 and a 12. Next, we insert the 25. 25 is less than 34, so it drops to the left subtree, and it gets inserted into this leaf node with the 8 and the 12. More room. 8, 12, and now the 25 is greater than both of them, so it goes to the right. Now, once again, we have a 3 node that's turned into a 4 node, and we can't have that in a 2-3 tree. So to reconcile that, we split it up in the same way that we did in the example. We're going to raise the 12 up to be with the 34, and we're going to drop the 8 and the 25 to be their own nodes. Next, we need to insert this 5. 5 is less than 12, and it's less than 34. And so it drops down to the leftmost subtree. Note that when we get to this point where we are now needing to compare this 5 with a 3 node, we have to compare it with both these values. We have to say, is it greater than 34? Is it less than 34 but greater than 12? Or is it less than 12 and less than 34? So the 5 goes down to the left of this node, and we get to this leaf node with the 8. We can go ahead and insert the 5 with the 8. Next, we have 53. The 53 is greater than 12 and it's greater than 34, so it goes to the rightmost subtree. And then once again, it's at a leaf, so it gets inserted with the 49. Next, we have a 29. The 29 is less than 34, but greater than 12. And so it's going to take the path that has not been taken yet, and it's going to go right down the middle. It's going to join in with this 25, and it's going to give us our last 3 node, which is 25, 29. So we can see that this 2-3 tree that we end up with from this order is not the one that it is asking for in the question. Let me pull up the question tree real quick so you guys can remind yourselves that it is not the one that we're looking for. We're looking for a 2-3 tree with 25 at the top, 8 and 34 on the next level, and then 5 and 12 with alongside 29 and 49 paired with 53. So this is not the tree that we're looking for, so we're going to go on to the next answer. Write down A is not the correct answer. All right. Next sequence we have is 25, 12, 34, 49, 8, 29, 53, and 5. This is B that we're looking at right now. We insert the 25 as normal first on the top. Then we insert the 12. 12 is less than 25, so it goes to the left. Then we insert the 34. 34 is greater than 25, so it goes to the right. And we now notice that we've gone from a 3 node to a 4 node, and we need to reconcile this. So to fix that, we split off the 25 and we send it up. And then we send the 12 and the 34 to be their own nodes on the side as children of the 25. Next, we have 49. 49 we insert. 49 is greater than 25, and so it goes to the right subtree, and it joins with this leaf node with 34. Next, we have 8. 8 is less than 25, so it goes to the to the left subtree, and it joins the 12. And that is a leaf node, so we can go ahead and insert it right in. Next, we have 29. 29 is greater than 25, and so it goes to the right subtree. And because it is less than both 34 and 49, it goes to the left of these two values. And once again, we're left with a 4 node that we need to reconcile. So we are going to fix this by sending the 34 up to join the 25. And then we're going to split off the 29 and the 49 to be their own nodes. Or looks kind of funky. Next, we insert 53. 53 is greater than 25, and it's greater than 34. So it goes to the rightmost branch, and it joins the leaf with 49. Then we see we've got one value left, the 5. We insert the 5, and we see that 5 is less than 25 and less than 34. And so the 5 goes down to this leftmost subtree, and it joins the 8 and the 12, because that is a leaf node. 5, 8, and 12. And we once again have a 3 node turning into a 4 node, and that's not allowed. And so the way that we fix it is that we push the 8 up, and we're going to leave the 5 and the 12 down. This is the first time in the examples so far that we've shown that we have a 4 node causing the creation of another 4 node, and I'm going to show you exactly what I mean by that. So the 8 is going to get pushed up, and it's now going to join the 25, and the 34. We're going to deal with that in a second. We're going to first fix this part, and then we will deal with that for node. And so because of the fact that this now is a for node, we now have 4 children of this top node. So now we can see we've got a for node on top, and we need to deal with this one too now. So the way that we do it is the same way that we've done it before. We're going to take the middle value of 25 and we're going to push it up. And then we're going to split off the 8 and the 34 to be children of that 25. Move this up a little bit more. So we're going to have 25 be the top node. 8 is a child of that on the left. 34 is the right child of that. And 5 continues to be the left child of 8. 12 continues to be the right child of 8. The reason that we're doing that is because 12 is in between 8 and 25. And so it becomes the right child of 8. This goes down to, this key goes down to this child. That key goes down to this child. And then we have the 29, and we have this other 3 node of 49 and 53. This is the final 2-3 tree that we get from answer B. We can compare it with the tree given, which shows 25 at the top, 8 on the left child, 34 on the right child, 5 and 12 in the left and right child of the original left child, and then 29 along with 49 and 53 both in the same node. We see that every node along the way has these exact same values. And so this is the correct answer that we're looking for, B. We could also go through the other answers just to verify that they also are not correct, but this whole process is a little lengthy, so I'm going to leave that to you guys to do on your own time.